Okay, AP scholars, we are here and we are going to take a look at Java. Whoa, Java. Remember this, all these images and notes and things will be available to you. This document will be coming out to you pretty soon. So Java, we talked about how it sort of combined both the compiler and the interpreter together. And it's kind of weird, but let's just take a look at it and figure out what's going on. So we have our editor where we type in our code, right? And that is going to create a source code file. And that's, going to be our Java code and stuff. And we're going to have lots of those this year. And Java has a compiler. JavaC.exe is the compiler for Java. And it will turn that source code into machine code and make an executable file, just like a compiler. But here's the crazy thing about it. This compiled file, these machine instructions, this is known as Java bytecode, by the way, or JBC. This does not run on any CPU in the world. It is not made for an actual CPU. It does not have machine instructions for a real machine. It has machine instructions for a virtual machine. And that's what Java Virtual Machine is all about, the JVM. The JVM is actually an interpreter that will live interpret the Java bytecode machine instructions into the machine instructions of whatever hardware the JVM is installed. So every Android phone has a JVM, for example, and whoever is making Android, I actually don't know who's in charge of Android. Is it owned by Google at this point? I'm not too sure. But whoever puts out the latest version of Android, they compile it to Java bytecode, and that ships. And then that Java bytecode is being live translated to my LG phone's CPU, so that it can run the Android operating system. And then another phone will have a JVM installed on it. Maybe it's not LG, maybe it's Motorola, and it's live translating that same Java bytecode, but it's translating it to the machine instructions for its hardware, and so on and so on. So all these different phones can run, this interpreted Java bytecode. So, okay, how does this make things better? So I guess what I should start off with is saying, why did they choose to do this? What was the problem they were trying to solve? So for Java, Java was born in the dawn of the internet age. And the creator of Java was trying to solve the problem of how can you deliver programs in a web browser? How can you deliver some kind of interactive program on the internet? So if you think about compilers, he was thinking compilers aren't a good idea because I can't run that program everywhere. If I write a compiled program that lives in a web browser, well, it's going to need to be compiled for that particular machine. So if a person has a Mac, maybe they can use it, but the person who has a PC can't. And you have to have two different websites for two different kinds of computers. And there's other kind of computers out there. Especially in the 1990s, it wasn't quite so streamlined into like two different particular brands of computers, and there was a little bit more competition out there for different kind of CPUs and stuff. Not to mention older computers that needed to be serviced as well. You needed to be included in this interesting new web experience, right? So compilers are kind of out. That doesn't work unless you want to have McDonald's.com for Mac and then McDonald'sPC.com for PC, and that's unwieldy. That's not great for user experience. So compilers, no go. Interpreters, I should scroll up and have these in front of me. Interpreters would work a lot better in terms of the cross-platform nature for delivering some kind of content online, some kind of interactive experience, some kind of program. But then there's the problem that, they expose the source code. And the people that are writing Java were thinking of writing it for people that want to profit from their programs, which is, wow, what a revolutionary idea. And obviously, Silicon Valley is all about the profit. So if the interpreter is the obvious way to go, but if you want to have some kind of proprietary software that not just anybody can just rip off, well, I guess you're gonna need to not use an interpreter. So that's terrible sort of conundrum. You're sort of stuck between two bad choices. So this is where the creator of Java decides to put the two together. So here's the deal with Java. If you were running they were called applets at the time. So like application, but like a small one that lives inside of your web browser. Then you could run it from the Java bytecode. So the Java bytecode could be embedded into your website, and that means that you can't see the source code at all. It's all binary and hard for a human to read. And that solves that problem. And then the Java virtual machine can be installed on different computers. So you could have a Java virtual machine on a Mac, and you could have a Java virtual machine on a PC. And they could both go to the same applet and download the same Java bytecode and just interpret that and go from there. So we've now managed to hide the source code, and it will run on multiple computers. What about the speed issue though? Like, isn't this going to be really slow? So it turns out that translating Java bytecode to whatever machine instructions work for your computer or your phone or your whatever is actually much more efficient than translating directly from source code. Because bytecode, Java bytecode is very similar to machine instructions. So the process for translation is way faster, and Java bytecode's optimized for this. Like they designed Java bytecode to be fast to interpret, really, really, really fast. It's still not as fast as a compiled language, and it still needs you to be running an external program, a Java virtual machine. So that's why an iPhone, like Apple fanboys and fangirls always talk about, the Apple phone is like, oh, it's so fast. And it's true that they do have an edge on an Android user, because an Android phone, even the really good ones, they still have to run that Java virtual machine that does use up some memory, that does use up some CPU cycles, quite a bit, like a gigabyte of memory. I guess I don't know for sure if that's correct, but a reasonably large amount of memory. And an Android, the iOS operating system is compiled, so it will be faster, and they're running compiled programs, so it'll be speedier. And sometimes it allows them to have hardware that's sort of less impressive than some of the more speedy Android phones that are out there. But then they don't need it to be quite as impressive. So there's these pros and cons and interesting sort of benefits. But in the end, Java sort of does solve that problem. So what are its its pros and cons are sort of the best of both worlds, right? It's not the fastest, but it's pretty fast. It's faster than most interpreted languages. It hides the source code, so if that's a good thing for you, then it's a good thing for Java. If it's not a good thing for you, then not a good thing for Java either. But most people, often that is considered an advantage. Let's put it that way. And then the last thing is, it's definitely cross-platform. Nails the cross-platform checkbox, definitely. So that's fantastic. Hey, it turns out Java wasn't really used for web stuff at all. They came up with other solutions for that worked better. Applets were a thing. I can remember seeing them on the internet quite a bit, and people were excited about them. But Java turned out to actually be more useful for its cross-platform nature, for programming all sorts of different electronics, and things like the Android operating system is the perfect example of where Java found its real home. Supporting a wide variety of hardware, like all the different phones, is a good example of where Java shines. And it's all used and all over the place. And because it got such hype in the internet age, it also has just become a multi-use tool for any kind of programming solution. It's just a solid language all around. There's other reasons why why people use it. So that's sort of how the story of how this works. So now that you've heard this story, you're going to have a bit of a task to do. There's at the bottom here you have your assignment. So there's words to know, and these are the words here. What is a compiler? What does it mean to be cross-platform? What's an editor, executable file, etc.? So you can take a look at these words and make sure you can define them with a sentence. You can Google these things and see what the definition is, but try not just to memorize the words. Like just don't memorize what a compiler is. Understand what a compiler is. And if you don't understand from what I've said, it's not your fault. I can't see you. You can't ask questions right now. So maybe find a time to ask me questions. You can ask them in Teams. You can email them to me, or you could ask me in class if there's time. Or you can come in at flex time. Everyone seems to be busy in flex time, but try to find a time to come in and we can talk about it in person. So that's sort of the first question, is just define these terms. And then the second question is knowing the advantages and disadvantages of compilers and interpreters, and my typing here, and understand how Java attempts to get the best. Maybe I should say explain, or no, I see. Apparently it's late at night for me. So know the advantages and disadvantages of both the compilers and interpreters. So we already talked about those. And also understand how Java attempts to get the best of both worlds and the way it combines its two systems. So I would like you to sort of maybe write a short paragraph, doesn't have to be a long thing, that explains sort of the disadvantages of compilers. You can make it point form, I don't care. The disadvantages and advantages, of compilers and interpreters. Make maybe a little bit of point form notes on that. And also just try in your own words to explain how Java attempts to get the best of both worlds out of that. And then I'll make an assignment in Teams for you to hand that in, and you can send it my way. Mostly this is just going to be a way to make some structured notes for you to help you remember what these are all about. At some point there'll be a unit test for the first unit, and this material will be testable on that. Okay, so I'm going to stop the video here, and I'm going to come back with one last video I've decided that I want to use to highlight one important thing that I think is so interesting and will blow your mind. So there's a final fourth video right after this, which I think is important. So do come back for it. Okay, thanks everybody.